we'll quickly go through that, revise it because it's important and you should understand it. So when we are talking about mechanism, we are talking about mechanism of type of reactions. Which type of reactions are we talking about? Elementary reactions. मैकेनिज्म किस टाइप के रिएक्शन के लिए होता है? Why are we writing mechanism first of all? Let me. Why do we need a mechanism? नहीं समझा किसी को? कितने लोग को नहीं समझ में आया कल क्या हुआ था? Raise the hand. सबको समझ में आया then you should be able to answer the question. ऋतुजा, राइटिंग मैकेनिज्म ये टाइम पास के लिए कर रहे क्या? मर्तजा,
यस सर।
राइटिंग मैकेनिज्म जरूरत क्या है? टाइम पास कर रहे हैं सिलेबस में इसलिए कर रहे हैं कि कुछ उसका इम्पोर्टेंस है?
सर इम्पोर्टेंस है सर।
क्या इम्पोर्टेंस है वही तो पूछ रहा हूँ मैं.
सर एलिमेंट्री रिएक्शन में रेटिक्यूशन निकालने के लिए.
एलिमेंट्री रिएक्शन निकाल रहे हैं हम रेट इक्वेशन. मैकेनिज्म किसके लिए लिखते हैं हम? एलिमेंट्री और नॉन एलिमेंट्री. वैभव,
Both, sir.
both. Okay. Viraj,
Yes, sir.
right mechanism for elementary reactions or non-elementary reactions?
Sir, can you repeat the question once again?
Right mechanism for elementary reaction or non-elementary reaction?
Sir, elementary.
Nupur, नहीं आवाज आ रहा है. देवेंद्र, right mechanism for elementary or non-elementary reactions? Simple question. भूमिका, तो मैंने ask you समझ में आया कि नहीं? I asked you to raise the hand. Why are you hesitating? बात नहीं है, डिफिकल्ट टॉपिक है पहले बोला मैंने. और एग्जाम में एटलीस्ट वन क्वेश्चन आता ही है, इनसेम में भी आता है, फाइनल में भी आता है. फिर आपका मोस्टली कुछ ना कुछ पेपर बेस्ड एग्जाम होने वाला है. सो यू हैव टू बी प्रिपेयर्ड फॉर मैकेनिज्म. अगर नहीं समझ में आया तो पूछो, मैंने बोला था कल भी. आस्क इफ यू डोंट अंडरस्टैंड. देवेंद्र, कैन यू हियर मी?
Yes, sir.
समझ में आया कल जो किया था हमने?
हाँ सर.
सिंपल क्वेश्चन कोई आंसर नहीं कर पा रहा, क्यों? सब सो रहे हैं.
सर वो अभी रिकनेक्टिंग हो रहा था इसलिए मैं माइक्रोफोन अनम्यूट नहीं कर पा रहा था.
क्वेश्चन इज mechanism is written for which type of reactions, elementary or non-elementary?
सर एलिमेंट्री के लिए लिखते हैं।
दैट मीन्स आई फेल्ड एज अ टीचर यस्टरडे। आपको इतना डिफरेंस तक नहीं बता सका मैं, आपको किसी को समझा नहीं कि एलिमेंट्री रिएक्शन के लिए नहीं लिखते हम, नॉन एलिमेंट्री लिखते मैकेनिज्म का लिए। एलिमेंट्री रिएक्शंस के लिए डायरेक्टली रिएक्शन से हम रेट इक्वेशन लिख सकते, बताया था कि नहीं मैंने? कंपैरिजन ऑफ एलिमेंट्री नॉन एलिमेंट्री रिएक्शंस, that thing, right? When we did
Yes.
the comparison of elementary non elementary, we saw that. वो भी नहीं समझा आप लोगों को यानी। When you look at elementary and non elementary reactions, elementary reaction is single step reaction, elementary is multiple step reaction, and that is why we need to write what are those multiple steps for that reaction, right? And we said that elementary reaction, if I know the reaction, if I know this reaction like this one, I can directly write the rate of reaction like this, right? Reaction of CH3COH is equal to K into CH3COH. Some concentration. Actually, from reaction from the stoichiometry rate equation for elementary reaction. Whereas I can't do that for a non-elementary reaction. And that is why we need to break down a non-elementary reaction into a number of elementary reactions, which will help us derive the rate equation. Because ultimately what is important is rate equation, which is how do we get the rate equation? Right? रेट इक्वेशन कहाँ से आता है?
सर रेट इक्वेशन एलिमेंट्री रिएक्शन से आता है ना?
रेट इक्वेशन से आता है कि एक्सपेरिमेंट से आता है?
Experiments.
Rate equation is always a measured quantity. It is done based on kinetic studies in the laboratory. That is the only way to get the rate equation. Actual experiments करके rate equation derive किया जाता है. Reactions, we can write the rate equation just by looking at the reaction. Know that order of reaction is equal to sum of stoichiometric coefficients, right? ये अभी डाला हमने यहाँ पर. Of CH3COH is 1 और 1 है यहाँ पर राइट, यहाँ पर सिमिलर C2H5OH का भी 1 है. So I can directly see the order of reaction from the stoichiometry in case of elementary reactions only. Whereas if I look at non-elementary reactions like this, I cannot write order as कि हाइड्रोजन का 1 रहेगा और ब्रोमीन का 1 रहेगा और 2 रहेगा. Because you have seen HBr का rate equation is very complex, right? दिखाया था मैंने आपको बीच में. Right, so we have seen this experimental rate equation of HBr formation, right? It is very complex. Whereas from reaction, we'll see that this is 1, this is 1. But यहाँ पर 1 1 नहीं है, यहाँ पर हाफ आ गया. यहाँ पर 1 है. But यहाँ पर नीचे में ये भी टर्म आ गया. That means it's not an elementary reaction, it's an overall reaction. So now we need to find out why is it like this, and that is why we write the rate mechanism. If I propose a number of elementary steps, because now non-elementary reaction is a multiple step reaction, so I can propose number of steps And based on those number of steps, I can derive a rate equation which may match with this one. समझ में आया आप लोगों को?
Yes, sir.
अभी किसी को डाउट है तो पूछो, बिकॉज ये टॉपिक पर एक दो क्वेश्चन आते ही हैं. Comparison of elementary and non-elementary reactions, comparison of order and molecularity, then at least one mechanism. और नहीं समझा तो स्ट्रगल करते रहोगे बाद में.
हेलो सर, जो मैकेनिज्म होता है वो हम पहले देते हैं कि एक्सपेरिमेंट करने के बाद देते हैं?
क्या बोल रहे हैं?
मैकेनिज्म जो हम लिखते हैं ना, जिसमें जो एलिमेंट्री रिएक्शंस रहते हैं वो हम पहले लिखते हैं कि जो हमारे एक्सपेरिमेंट किए उसको वैलिडेट करने के लिए लेते हैं.
एक्सपेरिमेंटल रेट इक्वेशन को वैलिडेट करने के लिए लिखते हैं. What we get from experiment, we try to justify based on theory कि क्या होगा. कल बोलता था कि anywhere you go in any subject you take, there's always a theory. Theoretical physics बताया था मैंने आपको, experimental physics रहता है. Right? You get data for black holes, but theory किसी ने पहले propose करके रखा है. That's possible if theory is easy, or rather people understand the theory. But then experimental data से अगर validate नहीं हुआ, then theory changes. Somebody will come up with a new theory. So in this case, yeah, I can write the mechanism, but then I need to validate with experimental data. You can go from theory to experiment or experiment to theory, both ways. Any other questions? ठीक है? Okay, so let's move on to the next topic. Molecularity order समझा था आप लोगों को? Difference between molecularity and order. What is molecularity?
Number of reactants, number of molecules of reactant taking part in the elementary reaction.
Yes, again, elementary reaction. It's always for elementary reaction, not for non-elementary reaction. And what is the order? Ritesh?
Sir, stoichiometric coefficients.
Stoichiometric coefficient. Viraj? Dikshita?
Sum of the powers of concentration terms in the rate equation.
Yes. An experimental quantity. Stoichiometry से नहीं मिलेगा rate order मिलेगा stoichiometry से only in which case? In which case you'll get order from stoichiometry?
Elementary reaction.
Only for elementary reactions. So you cannot say कि stoichiometry से हमारे को order मिल जाएगा, because it's applicable only for elementary reactions. अभी अभी देखा हमने, right? So it is only for, if you write a general thing, it's a sum of powers of concentration of reacting species of rate equation. Rate equation is always found experimentally. Right? And because it is experimental quantity, order can be zero, it can be integer, it can be fraction. Whereas molecularity can never be zero, because zero molecule से कुछ नहीं होने वाला है. Fractional molecule से भी reaction नहीं होने वाला है. It has to be integer, 1, 2 or 3. And it's a theoretical quantity, molecularity, because it's based on stoichiometry, whereas order is rate experimental quantity. Right? So this is for elementary, this is for overall reaction. Okay. So then we have seen देखा हमने कि वी कैनॉट राइट रेट इक्वेशन लाइक दिस। अगर ये रेट इक्वेशन है, ये एलिमेंट्री रिएक्शन है, तो रेट इक्वेशन ये आएगा, ये नहीं आएगा, बिकॉज दिस इज एलिमेंट्री रिएक्शन, दिस इज नॉट एन एलिमेंट्री रिएक्शन। ओनली फॉर एलिमेंट्री रिएक्शन वी कैन राइट रेट इक्वेशन फ्रॉम रिएक्शन। राइट, देन वी सेड कि ठीक है, अभी मैकेनिज्म देखने का है, तो वी हैव टू सी हाउ डू वी रिप्रेजेंट नॉन एलिमेंट्री रिएक्शंस। राइट, ये सब मिसमैच होता है, हम देखा हमने। तो काइनेटिक मॉडल्स लिखा था हमने नॉन एलिमेंट्री रिएक्शंस के लिए। सो अज्यूम दैट मीन्स a non-elementary reaction is essentially a series of steps or series of reactions which are all elementary. Why should they be elementary? Why should we break down a non-elementary reaction in terms of elementary reactions? Siddhi?
सर क्वेश्चन नहीं समझा।
Why should we break down? See, we are saying that non-elementary reaction is a multiple step reaction, right? Whereas elementary reaction is a single step reaction. So now what we write mechanism, we are breaking down a non-elementary reaction into multiple steps. And what I am saying is that all those steps or all those reactions which we are saying that they constitute the non-elementary reaction, they should all be elementary. Why?
सर रेट ऑफ इक्वेशन के लिए।
Right, because if you write non-elementary reaction in terms of elementary reaction, we can write the rate equation for those steps just by looking at the stoichiometry. Right? If you write non-elementary reaction in terms of non-elementary reactions, it's not of any use because you cannot write the rate equation. समझ में आया सबको ये? Why should the steps be all elementary reactions?
सर,
Yeah.
लेकिन हमें कैसे पता चलेगा कि वो एलिमेंट्री है या नहीं?
गुड क्वेश्चन। तो पता चलेगा अपना डेरिवेशन से। अगर अपना जो रेट इक्वेशन डिराइव करते हैं हम बेस्ड ऑन मैकेनिज्म, if it matches with your experimental rate equation, then the steps which you assumed are correct. It's all hypothesis, right? I said it's a whole hypothesis, theory है पूरा. We are saying कि okay, we propose that this non-elementary reaction takes place like this in terms of step 1, step 2, step 3, जो भी रहेगा, right? And if based on those steps we derive an equation and that equation matches the experiment later, that means our steps are correct.
Yes.
Okay. So now we are assuming that there is elementary reaction, a sequence of elementary reactions occur in non-elementary reaction, which we cannot measure, right? Because the intermediates are formed, they are in very small quantity, or as soon as they are formed, they decompose. So it's not measurable quantity, but we assume that okay, intermediate form होता है और वो हमारे को final product देता है. But we can measure the reactants and products because those are insignificant quantities. We can measure the reactants and products, but we cannot measure the intermediates. Right? So we said that okay, we propose a series of steps which are constituting the non-elementary reaction, and it can be anything. You know, I have just given some example here. It doesn't matter, just an example. Right? Now, based on this thing, we'll predict an equation or reaction rate equation, and if predicted rate equation matches the experiment data, then what we have proposed or hypothesized is correct. ठीक है, ज्योमेट्री में प्रूफ करते थे ना हम, QED करके थे, ये प्रूव करना है करके. So similarly, what we are saying is theory if matches with experiments, then what we propose as theory is correct. ठीक है?
Yes, sir.
So then we said okay, that what types of intermediates can be there, and this is based on chemistry, right? You have done this in chemistry. It was just a revision of that. So free radicals हो सकते हैं, which will have unpaired electrons represented by a dot, ऊपर में dot आता है. These are unstable and highly reactive free radicals. Right? CH3 dot, C2H5 dot वगैरह एग्जाम्पल दिया था. Whereas compounds are stable, but these free radicals are not stable. So as soon as they are formed, they decompose. Or it could be ions. So Na plus OH minus वगैरह ions हो सकता है, right? Or it could be molecules if it is series reaction, like A goes to R goes to S, and if R is very small quantities, if it is in small quantity, then it's very difficult to measure that, but it may be formed and may decompose immediately. So if it is highly reactive and mean lifetime is very small, that means the moment it forms, it decomposes. Okay. So fourth one which we saw is transition complex. Transition complex is activated. Basically it's basically a intermediate which is very reactive, and it is transition complex because it transitions from reactants to products. Right? The reactants will give some transition complex, which will again get transformed to products. So that's why it's called transition complex or activated, because it is very reactive. So depending on the reaction, we may propose a different intermediate, right? So A plus B reactant will form some activated complex, and then it will give product in the second step. So we have types of intermediates.
Yes, sir.
Okay. Then after that we have to propose a mechanism, right? क्या steps क्या होते हैं वो बताना पड़ेगा. So it could be non-chain reaction or chain reaction. ये भी आपका पढ़ा हुआ chemistry, nothing new, right? Non-chain reaction में intermediate form होता है और वो decompose हो जाता है. There's two steps basically, right? Whereas chain reaction में normally there are three steps.
सर
Yeah.
नॉन चेन में वो दो स्टेप्स कौन से, एक इनिशिएशन एंड
ये एक स्टेप है एलिमेंट इंटरमीडिएट बनने का और डिकम्पोज करने का.
सर नॉन चेन रिएक्शन में कैसा नाम है कि इनिशिएशन, प्रोपगेशन एंड टर्मिनेशन?
ऐसा कुछ
वैसे
नहीं है,
कुछ
इंटरमीडिएट फॉर्मेशन एंड डिकम्पोजिशन है. फॉर्मेशन ऑफ इंटरमीडिएट एंड डिकम्पोजिशन इंटरमीडिएट नाम नहीं दिया, बट देयर आर ओनली टू स्टेप्स. एक स्टेप में इंटरमीडिएट बनता है, दूसरे स्टेप में इंटरमीडिएट डिकम्पोज होता है. You can say initiation and decomposition, doesn't matter, or initiation and termination, doesn't matter. But नाम नहीं दिया गया, इसको किसी ने नाम नहीं दिया है, so that is why there's only two steps: intermediate formation and decomposition. Again, as I said before, these are all elementary reactions, right? We are going to always write elementary reactions, not non-elementary reactions. ठीक है?
यस सर.
Whereas in chain reaction there are three steps. Okay? So there's a chain initiation step where the intermediate is formed. Then there's a chain propagation step where the intermediate reacts with other reactant to give some product plus another intermediate. Okay? Whereas what I'm saying is this step is not present in non-chain reaction. Confuse mat karo isko. It is not part of non-chain reaction, but it's part of chain reaction. And then in the third step, the intermediate is decomposed to give product, and it's called termination step. Because then the intermediate is not available after step 3, but then this is one which is actually propagating. That means intermediate से intermediate बन रहा है और product बन रहा है. Destroy नहीं हो रहा है intermediate. ठीक है, डिफरेंस समझ में आया, चेन रिएक्शन नॉन चेन रिएक्शन। And all this comes from chemistry. So knowledge of chemistry is important because जो chemistry में पढ़ते हैं आपको पूरा, it can be used in this step. So propagation step. Right? Propagation step था, right? Chain propagation step. This is essential part of chain reaction. Intermediate is not consumed, or it acts as a catalyst for conversion of reactant, and each intermediate can catalyze a long chain of reactions before it is destroyed in the termination step. ठीक है, समझ में आया? Any questions so far? पूरा रिपीट था कल का, but it is worth it if you have understood it. Any questions on these two steps? है तो अभी पूछो. Nothing wrong in asking. Okay, if there is no step, no reaction, no question, then let's proceed to examples of chain mechanism. So we have to basically combine these two. We have to propose an intermediate. What is the intermediate out of these four which is formed? समझा ना? We have to select इन चार में से कौन सा intermediate form होता है, and then whether it reaction chain reaction or non-chain reaction. So it's a combination of these two to form the mechanism. Right? So it can be different things. So look at one example is free radical लिया हमने और chain reaction mechanism लिया. Okay. So for HBr formation, somebody has proposed that bromine gives 2Br dot initiation and termination. Why is it initiation and termination? Why is it termination also?
तो radical formation reversible भी हो सकते हैं.
Right. Because we are written here as reversible. So when it is reversible, when it goes in this direction, it is termination. When it goes in this direction, it is initiation. Understand this when you write a reversible reaction, what it means. ये आपका basic chemistry है. When you write a reversible, like this one, is termination. It's a irreversible reaction. Right? And then Br dot, which is activate intermediate, plus hydrogen gives HBr plus H dot. So this intermediate is giving another intermediate. So it's a propagation step. Then H dot reacts with Br dot to give Br dot. It's giving one intermediate, giving another intermediate. That's why it is chain propagation step. And it's not one, there are two chain propagation steps here. Right? And then finally termination is H dot and Br dot gives HBr. So based on this, somebody has derived an equation which matches with this rate equation. ठीक है? Any question? We'll see the derivation of rate equation, but this is just an example के कैसे हम intermediate plus reaction scheme combine करके एक mechanism सब propose कर सकते हैं. Any questions?
अभी assume किया है क्या कैसा होगा?
मैंने से propose hypothesis का मतलब क्या होता है?
Yes, sir.
प्रपोजल रखा,
समझा।
इज ऑलवेज एन अजम्पशन, नहीं थ्योरी रहता है, ये कि बोलते हैं कि हम ऐसा ऐसा होता है, and then based on experiments you prove. If it matches the experimental data, then yeah, then my theory is correct. If the experimental rate equation and theoretical derived rate equation do not match, then theory is wrong, because what is important is experimental values, experimental data. Okay?
Yes, sir.
Okay. So then we can have another combination, molecular intermediates and non-chain reactions. So there can be different combinations. 4 type of intermediate लिखे थे हमने और 2 type of reaction देखे थे हमने, chain reaction, non-chain reaction. So we can combine any of those based on requirement. So if you look at enzyme catalyzed fermentation reaction, some A reactant A in presence of enzyme gives the product R. Experimental rate equation is given by this equation, which is called Michaelis-Menten equation or mechanism. R of R is equal to K into concentration of A. A is essentially a substrate. Then E naught, concentration of E naught, that is the enzyme concentration, initial concentration, and M is a constant. The denominator divided by M plus A. So somebody has derived this equation, and that's Michaelis-Menten दोनों लोगों ने मिलकर बनाया. And they said that enzyme reactions are normally represented by this type of rate equation. और उन्होंने कुछ mechanism भी दिया, which is given below. So in their mechanism, A reacts with enzyme to give an intermediate, A into enzyme star, right, activated complex or transition complex, and A into enzyme star gives R plus enzyme. The enzyme ज़्यादा ऐड नहीं करना पड़ता है. If you go to alcohol industry, आपने देखा होगा, I don't know whether you have visited alcohol industry in industrial visit or not, but fermentation reaction होता है वहाँ पर. देखा किसी ने alcohol industry?
Yes,
सर
sir.
झायमेज होता है झायमेज
क्या होता है उसमें, अल्कोहल प्रोडक्शन कैसे होता है?
झायमेज एंजाइम यूज करते हैं उसमें.
राइट. और सबस्ट्रेट क्या रहता है?
सबस्ट्रेट वो मोलेसिस, वो मीडिया रहता है शुगर और वाटर का.
मोलासेस लेके उसको एंजाइम से रिएक्ट करते हैं और यू गेट अल्कोहल, राइट?
यस.
So molasses essentially is sucrose plus glucose. With zymes it reacts to give alcohol and or CO2. So those two have worked, and I think it's mainly applicable to all what you call reactions which involve some enzyme. Okay. And third one is you can take a transition complex and non-chain reaction. So what we can do propose is 2 molecules of A, give A star plus A. So we are saying a formation of an energized molecule A star, and A star plus A gives A plus A. That is basically यहाँ पर reverse कर सकते हैं इसको. We can represent this way or that way, doesn't matter. इसको reverse कर दिया तो ये हो गया, right? You can write this way or that way, doesn't make any difference. And then we have decomposition of activated complex or energized molecule A star giving R plus S. Okay. So for that example is decomposition of azomethane. Azomethane is CH3 twice N2 gives C2H6 plus nitrogen. So essentially it is A gives R plus S. Its rate equation somebody has found out. R of nitrogen is equal to K into CS, that is enzyme concentration square upon 1 plus K prime into concentration of enzyme. And mechanism somebody has proposed So 2 molecules of enzyme, azomethane, CH3 twice N2 gives CH3 twice N2 star, that is activated molecule, plus CH3 twice N2, and then second step, CH3 twice N2 star decomposes to give C2H6 plus nitrogen. And then based on that, they derived this rate equation, which is matching with experimental values or data. Okay. So different ways you can combine. You can select an appropriate intermediate, and then reaction scheme kya hoga, chain reaction, non-chain reaction, and propose a number of steps which can be used to derive the equation. We'll see how to derive the equation. It is the next step we are going to do. But this is essentially a example of how it is done. Okay, any questions so far? Okay, so if there are no questions, if you look at this rate equation, R nitrogen K Ca by Ca square upon 1 plus K Ca, we can write in terms of partial pressure also. Why we can write in terms of partial pressure? कैसे replace कर सकते हैं?
PA by RT.
Right, because for gas phase, so we can get right in this equation, this form. And if you are doing a gas phase reaction, in this case, we can look at pressure. If you are doing the reaction at high pressure, तो ये term जो रहेगा is going to be quite high compared to 1. And then denominator में you can ignore 1. So what you'll get is K into Pa square upon K prime into Pa, where you can write this as another term, another constant, and then Pa. So it becomes a first order reaction at high pressure. Whereas यहाँ पर देखा तो यहाँ second order दिखता है, यहाँ पर नीचे it's a complex thing, right? But you can look at the rate equation at different operating conditions. And operating conditions include temperature, pressure, etc. So pressure अगर देखा हमने, so it becomes a first order reaction at high pressure. And at low pressure, then this quantity becomes very small, and then we can ignore that quantity, and 1 is more than that, so we can replace denominator में this becomes 0, so we get 1. So it becomes like R of nitrogen is equal to K into Pa square. That's second order reaction रहता है. So depending on different operating conditions, pressure low रहा तो it becomes second order reaction, pressure high रहा तो it becomes first order reaction. And this is a test. So somebody must have done the experiments, found out कि high pressure पे क्या order of reaction है, low pressure पे क्या order of reaction है, and then this mechanism propose किया, rate equation आया, and that proves कि pressure high रहा तो क्या order रहता है, pressure low रहा तो क्या order रहता है, and that is the way to prove कि mechanism बराबर है. ठीक है, any questions?
सर कंसंट्रेशन लेके भी किया जा सकता है ना, तो
Concentration भी किया जा सकता है. You can do it either way. Same thing you can do for concentration also. Doesn't matter. High concentration रहेगा तो you can say this term is much more than 1. Low concentration रहेगा, this is much less than 1. Yeah. You can do for both concentration as well as pressure, but this is normally in gas phase, इसलिए डाला था.
यस.
Okay. So next is, once you have that what you call some mechanism हमने propose किया, ये intermediate form होता है और ये ऐसे reaction होता है, then we need to test it again in models, right? तो कैसे टेस्ट करेंगे? We have to some way of deriving. जैसे हमने propose किया ये reaction, but equation कैसे derive करेंगे? ये propose तो कर दिया mechanism. How to derive equations from here? So for that we need to have some hypothesis again, right? So we propose two types of intermediates. Intermediate form वो चार types है, लेकिन वो कैसे form होता है, कैसे decompose होता है, वो भी propose करना पड़ेगा, right? That was, so we say type 1 intermediate with unseen and unmeasured intermediate X present in small concentration such that its rate of change is equal to 0. Right? That means we say X. That means intermediate concentration is small. Concentration of intermediate is small, and rate of change of intermediate is equal to 0. And this is called steady state approximation. That means that steady state concentration is very small and rate does not change, and that is why it is called steady state. ठीक है. So mechanism 1 and 2 हमने देखा था ऊपर, right?
सर ये फिर से जरा बताना स्टेडी स्टेट का.
स्टेडी स्टेट का मतलब क्या होता है? You studied fluid mechanics, you studied heat transfer, you studied mass transfer. What is steady state?
Constant with
सर
the
टाइम के साथ हुआ है
हीट ट्रांसफर में जो स्टेडी स्टेट किया था उसका मतलब क्या था? हीट ट्रांसफर जो पढ़ा आपने, स्टेडी स्टेट पढ़ा कि डायनामिक पढ़ा? मास
सर जो टाइम के साथ वेरी नहीं होता.
हाँ, जो टाइम के साथ वेरी नहीं होता, राइट? व्हाट डज दिस मीन?
सर स्टेडी स्टेट.
समझा ना? dx by dt equal to 0 का मतलब क्या होता है?
steady state.
Steady state. What you are studying in heat transfer, mass transfer, fluid mechanics, जितना स्टडी किया होगा, it's always under steady state. You rarely study unsteady state in second year, third year. BE में जाके PMS पढ़ोगे तो उसमें unsteady state आएगा. It is not easy to handle unsteady state. Okay. So here we are assuming कि जो इतना भी concentration है इसका intermediate का, it is at steady state. And that's why it's called steady state approximation. And ये हमने पहले बोला because we have said intermediate is always in small quantity, right? And that's why we are saying कि ये जो रहेगा small quantity रहेगा. ठीक है?
तो मतलब ये सिर्फ इंटरमीडिएट के लिए है क्या?
इंटरमीडिएट के लिए ही अज्यूम कर रहे हैं हम. Only for
उसका कंसंट्रेशन चेंज नहीं होता.
Yes. Okay.
सर फिर प्रोडक्ट कैसे फॉर्म होगा ना, मतलब इंटरमीडिएट को जीरो कर देंगे तो?
इंटरमीडिएट जीरो नहीं किया हमने, रेट ऑफ चेंज ऑफ इंटरमीडिएट जीरो किया. दैट्स अ डिफरेंस. इंटरमीडिएट इज स्मॉल बोला, इंटरमीडिएट जीरो नहीं बोला हमने.
सर तो फिर प्रोडक्ट भी कम फॉर्म होगा ना, क्योंकि इंटरमीडिएट पे ही डिपेंड है.
कुछ नहीं है देवेंद्र. You have to see this is basically a combination of all these things. Intermediate form हुआ, जैसे यहाँ पर हम रिएक्शन आ गया मैकेनिज्म प्रपोज किया, राइट? सपोज वी लुक एट दिस मैकेनिज्म. जो इंटरमीडिएट गया, ये इंटरमीडिएट जो फॉर्म हो रहा है, राइट? व्हाट वी आर सेइंग इज द रेट ऑफ चेंज ऑफ दिस इज स्मॉल और जीरो. दैट डजंट मीन इट इज जीरो. इट इज देयर. जितना फॉर्म हो रहा है यहाँ कंज्यूम हो रहा है, फिर दूसरा फॉर्म हो रहा है, कंज्यूम हो रहा है, राइट? रेट ऑफ चेंज इज नॉट चेंजिंग, इज जीरो. दैट मीन जितना भी है रेट, जितना भी कॉन्सेंट्रेशन है, दैट इज कांस्टेंट. दैट इज इनफ फॉर द रिएक्शन. रिएक्शन कम होगा ऐसा कुछ नहीं है, बिकॉज नाउ यू आर टॉकिंग अबाउट प्रोपेगेशन. होते जा रहा है, एक इंटरमीडिएट डिस्ट्रॉय हुआ, दूसरा जनरेट हो गया. इट्स नॉट रियली गेटिंग कंज्यूम्ड. कंज्यूम यहाँ पर ही हो रहा है सिर्फ लास्ट स्टेप में, बट ये प्रोपगेशन स्टेप ये थाउजेंड्स में ना, थाउजेंड्स ऑफ स्टेप्स होता है, इट कैन जनरेट थाउजेंड्स ऑफ इंटरमीडिएट्स. So intermediates are not going to be zero. It's only small. It's not measurable. समझा?
हाँ सर.
Okay. So we can combine ये जो अभी इतना मैकेनिज्म प्रपोज किया है, बोलते हैं कि जो फर्स्ट स्टेप है, ये फर्स्ट मैकेनिज्म था फ्री रेडिकल चेन रिएक्शन, राइट, मॉलिक्यूलर इंटरमीडिएट नॉन चेन रिएक्शन, जितना भी है टू मैकेनिज्म, राइट. जैसे अभी आप देखेंगे फर्स्ट मैकेनिज्म था, राइट. फर्स्ट मैकेनिज्म में क्या था, ये इक्वेशन था अपना. इक्वेशन में क्या है, सम कॉन्सेंट्रेशन टर्म डिवाइड बाय, so it is essentially concentration upon 1 plus concentration term. ठीक है, फॉर्म forget about power and species वगैरह, but this form is concentration upon some 1 plus some concentration, right. If you look at second mechanism वैसे ही है, concentration upon 1 plus concentration, बराबर. ये भी कॉन्सेंट्रेशन टर्म है, ऊपर में ये कांस्टेंट है, इसको डिवाइड किया तो हम गेट द सेम थिंग 1 प्लस कॉन्सेंट्रेशन. ठीक है. थर्ड मैकेनिज्म जो प्रपोज किया था, ट्रांजिशन कॉम्प्लेक्स नॉन चेन रिएक्शन, इसमें भी सेम है, राइट. बराबर, कॉन्सेंट्रेशन 1 प्लस कॉन्सेंट्रेशन. और चौथा वाला क्या देखा था, क्या हमने नहीं देखा था. सो ये जितना भी है, इसमें हम यू कैन यूज टाइप 1 अप्रोक्सीमेशन, स्टेडी स्टेट अप्रोक्सीमेशन. विल सी दैट एन एग्जांपल, हम एक्चुअल डेरिवेशन करेंगे एंड देन विल सी हाउ वी कंबाइन इंटरमीडिएट विद द रिएक्शन स्कीम विद द टाइप ऑफ इंटरमीडिएट. स्टेडी स्टेट अप्रोक्सीमेशन है, कुछ और है, राइट. तो टाइप 2 इज अगेन इंटरमीडिएट के लिए हम क्या अज्यूम कर रहे हैं कि when homogeneous catalyst with initial concentration C0 is present in two forms, three catalysts are combined to form intermediate X. So C0 initial concentration gives C plus X, right, some catalyst. So assume के dx by dt equal to 0. आप x equal to 0 small नहीं बोल रहे हैं, हम dx by dt equal to 0 बोल रहे हैं. That means we are saying कि we are assuming equilibrium. Equilibrium का मतलब क्या होता है, what does equilibrium mean?
Forward rate equal to backward rate.
Right. So we write some equation, some reaction in which we'll see that reactant A plus some catalyst gives intermediate, some intermediate. Right. So you can write A plus C gives intermediate, and we are talking about reversible reaction here, and that's why we can write equilibrium. Right. So we can write equilibrium constant K is equal to nothing but concentration of X, that is product, upon concentration of reactants. Right. That's how we define equilibrium constant. Or we can write dx by dt is equal to K1 into A concentration into C concentration minus K2 into X concentration, reversible reaction, and that equal to 0, right? We are saying dx by dt equal to 0. So we said dx by dt equal to 0 लिया हमने, so then we can get K1 by K2 is equal to K is equal to X upon A plus A and C, right? So in this case, we are going to look at all the
Sir,
intermediate. Yeah,
सर वो x क्या है, इंटरमीडिएट है क्या?
intermediate, right?
अच्छा.
X is intermediate.
ओके सर.
ठीक है. इन दिस केस व्हाट वी आर सेइंग इज ये जितना भी इंटरमीडिएट फॉर्म हो रहा है दैट इज इन इक्विलिब्रियम। तो जितना फॉर्मेशन रहेगा डिस्ट्रक्शन रहेगा, अभी दो स्टेप भी हो सकता है जिसमें एक में फॉर्म हो रहा है एक में डिस्ट्रॉय हो रहा है, राइट। तो यू टेक ऑल द स्टेप्स एंड से कि कितना भी हो रहा है दैट इज इन इक्विलिब्रियम। जो फॉर्मेशन डिस्ट्रक्शन रहेगा, जैसे इफ यू लुक एट दिस वन, दिस इज फॉर्मेशन ऑफ इंटरमीडिएट, and this step is just consumption or destruction. ठीक है, so these are in equilibrium. That means जितना फॉर्म हो रहा है उतना ही डिस्ट्रॉय हो रहा है. That doesn't mean it is zero. Again, Devendra, it doesn't mean it is zero. ठीक है, to understand that thing. So in that case, we can say dx by dt equal to 0 लिखा हमने, तो इक्वेशन लिखा हमने, and what you can get is this. Yeah. Any questions?
तो फिर सर ये इक्विलिब्रियम अप्रोक्सीमेशन हो गया ना, क्योंकि इक्विलिब्रियम से मान
या से इक्विलिब्रियम पहला वाला स्टेडी स्टेट था, second one is equilibrium approximation. There's a difference. That's why it is called equilibrium, no? तो पहला हमने देखा था that is called steady state approximation. Then we'll see कि जितना भी फॉर्म हुआ that is equal to zero. But it is combining, it's basically looking at कितना फॉर्म हुआ उतना rate is zero. But here we look at all the formation destruction things and we'll see examples. Then we'll understand better. We'll understand difference between steady state approximation and equilibrium approximation. Example देखेंगे तो you'll better understand it because that will be actually what you call fixing the concepts.
सर तो वो इक्विलिब्रियम कांस्टेंट कंसंट्रेशन पे डिफाइन होता है या रेट कांस्टेंट पे?
इक्विलिब्रियम कांस्टेंट किस पे डिपेंड करता है?
सर रेट कांस्टेंट पे भी है ना, फॉरवर्ड बाय बैकवर्ड।
थर्मो पे पढ़ा है ना हमने, थर्मो इतना पढ़ा, यूनिट 5 यूनिट 6 भूल गए क्या रे?
नहीं सर याद है।
फिर yeah, it is equilibrium constant is essentially a ratio of forward rate constant to reverse rate constant, but it is terms of in the concentration it is this also.
यस सर, क्लियर।
ठीक है,
हाँ
okay,
सर।
so tomorrow we'll continue with this thing. We'll see some examples. We'll see how do we combine intermediate with reaction scheme to form a mechanism, and then hypothesis क्या करेंगे. ये चारों combine करके we'll derive a rate equation for a particular reaction. Then you'll see how it is done. अभी टाइम नहीं है, so we'll not do it. ओके, और अगर टाइम मिलता है तो घर जाके थोड़ा पढ़ो, बुक में बहुत अच्छे से एक्सप्लेन किया हुआ है.